Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Okay, so the first questions all of you must be having in mind, and the question is, what is Docker? Right? What is Docker? What is Docker? So when I see Docker, it's a container, okay, management tool, right? Now this is the simple definition. What is Docker? It's a container management tool. Now if we find little bit, and if we get in little bit more deep inside this, then we need to find out tool, definition of tool, definition of management, and definition of container. Okay, this is the three questions we need to answer. So you know that, I mean, since we have evolved from last tens of thousands, whatever the years which we have, we've been using the tools all the time. And earlier we used to change the tools every 200 years, 100 years, 50 years. Nowadays, every 2 years or 1 year itself, we change the tools. But the question is, why we are using tools actually? Why we are using tools? And we are using tools only for three reasons. We change the tools only for three reasons: saving cost. That's all. Saving cost and save time for getting the work done, and improve the quality. Improve the quality. These are the primarily three reasons which we have. Using that, you can save cost. We can use the tools: saving cost, saving time, and improve the quality. Now you will be having a question, Rajesh: how Docker can save cost, how Docker can save time, and how Docker can improve a quality of which way? So these questions I'll come in a little bit later point of time. Management, I don't think so I have to define it, because human by default, by design, they're very good in management, and some of them are best in management. So I think you can understand that. But here also I must tell you here, management here means, let's say, VM management. So what you can do, VM management tools like VMware, VirtualBox, Hyper-V, EX, and all, many softwares are there, vSphere. So what they do, how do they manage virtual machines? So they create a VM, they start the VM, they stop the VM, all these things they do that, remove the VM, all these are the typical things they do that. This is called management. So here, what I'm trying to say is, here using Docker, you can create container. Using Docker, you can start container. Using Docker, you can stop container, and using Docker, you can remove a container. That's what management I'm talking about. And now, last and most important questions what we have is, what is container? Okay, what is container? And these questions I must answer in detail. This question I must answer in detail. What is container? So yes, what is Docker? It's a tool, it's a platform. For what? Running a container, managing a container. When I say managing, means it can include. So if someone asks you, hey, Docker, can you tell me the use cases? So using Docker, you can create a container, you can start the container, you can stop the container, you can remove the container. Then someone will ask you, hey, why do you need this at all? So you can say, hey, using this, you can save cost, save time, and improve the quality. But what? That is important. But what, in terms of what cost? So here I must tell you, the containers containers consume, please understand that, consume less CPU and RAM and no licensing cost, NO license cost. I'm writing in a short, please understand that. Compared to what? Compared to VMs. The same VMs which we are running from last 15 years. It's not a new technology, VMs, virtual machines. You can find the VM on AWS, Google Cloud, Azure. You can run VMs in the virtual machines, laptop. So all these things, the same VM. So containers consume less CPU, less RAM, no licensing cost compared to VM. So you tell me, let's say if you're running a data center with the VM and data center with a container, and if you consume less CPU, less RAM, and no licensing cost, of course it'll be cost effective. It's very simple, right? So if someone asks you why do we need a Docker, so simple. Docker and container consume less CPU, RAM, license, and no licensing cost compared to the VMs. Now next thing is, how come it saves time actually? So let me ask you, running an app in VM, how much time it will take? Let's say I'm just be very optimistic. If you're using cloud, 5 minutes. And if you're using clouds and if you have automation in place, like bootstrapping images and all stuff like that, like a Terraform or Ansible or maybe some custom images and all these things in place, then 5 minutes. 5 minutes is equal to 300 seconds. Now I'm saying, hey, can I run applications in container, and that too in 1 second? Yes, I said 1 second. So here, how much profit you are getting? Look at this, 300 seconds versus 1 second. You compare how much time you are saving. How much time you are saving. Okay, so in a simple way, you can run any apps in a container in a 1 second. Yes, I mean it, not 5 minutes. Physical machines will take much more than that. So now the question is, which way you improve the quality, and what quality you're talking about? Quality of software. Yes, quality of the software. Quality of the software means quality of the code and testing process. How? Which way? Let's say if you're using VMs, probably if you want to set up a dev environment, how much time you spend? 3 hours. Now, how much time you spend? Dev environment, few seconds. I repeat, few seconds. So that means you are working 8 hours out of that. Think about it, very simple logic. 8 hours you are working for the office, 3 hours you spend to create a dev environment or QA environment or pre-production, whatever it is. And now you are spending few seconds. So where you will spend time, the time which we saved, 3 hours or approx 3 hours, where you'd spend, of course you will spend in the quality of coding and quality of testing. Don't you think so? It's very simple logic. Are you understanding what I'm trying to say? So yes, you are able to improve the quality of the software if you are going and migrating to the container. That means if you are running application in a container, you can get all these benefits. So if someone asks you, tell me the benefits of Docker, why should I go and migrate? Why should we learn this? You should say all these benefits immediately. Okay, so now we have understood what is Docker. It's a container management tool, and why Docker is the regions, and what is the management is all about. So you can use in Docker, you can create a container, start the container, stop the container, and remove the container. But the most important question is still not answered. What is container? What is container? Okay, so if you really want to understand what is container, first question which you have to answer, first question which you need to answer is how or what are the components required to run any app. Very simple. If you can answer this question, I'm not saying container, I'm not teaching you container, I am teaching you computing now. If you really want to understand what is a container, then you need to answer what are the components required to run any app in laptop, in virtual machine, the one which you are using from last 40 years probably plus. You are using laptop or desktop from last 40 years plus. Laptop probably from last 25 years or maybe something like that. Correct? So do you have this answers of this question? Probably I will not ask you because many of you might not be having this answer, but some idea at a high level. But if you remember, I was having one Linux session, and in that also I covered this topic. So let me sum up this. See, first thing, you need a hardware. First thing, you need a hardware. Hardware means what? CPU, RAM, and storage. Okay, very simple. And after that, you need what? Operating system. Correct? Now, if you understand that operating system, it has a kernel. So if you want to run any application, for example, I'm using Apache. Okay, so this is Apache. I want to run it. So you got a hardware, you got an operating system. After that, what you need in operating system? Kernel. So you need one user, you need one user, because every application runs along with the user. Let me show you in the Windows easily. So where's the task manager? Task, search for this task manager. It's same thing with the Linux also. See here, look at my screen very carefully. See that, tell me one application. I'm running approx 300 applications running in my machine. I don't know, so many networking and system related. Tell me, look at this username. Do you see empty anywhere? See here? No. That means we need to run applications. It can be any application for the sake of you required one user. And then you required one network. One network, Apache need to be accessible from outside. So you need a network to access it. And you required one PID. One PID. What is a PID? I think I'll not get into the detail, but look at this. Tell me, these all are applications running. Do you see any application which is without the PID? Look at the PID column, PID ID. Where I'm trying to put it in a simple way. Okay, so if you want to run any applications, you need one user. Here it is. You need one PID, one network, and the last one which I need is one MNT. MNT means what? Aka. MNT means, here I must write it, Aka file system. File system means the place where you will store the Apache file, like a C Apache, OPT Apache, or something like that. So tell me, are you comfortable so far? If you want to run any applications, you need hardware plus operating system, which has the kernel, and then these are the 4 elements minimum you need it to run that application. Are you agreeing with it?
Yes.
Yes. Now guys, how do we get a CPU and RAM? See here, look at this here. Each PID, look at this, my cursor, CPU and RAM. See, every application is running, they require CPU and RAM. So this you see 0, that means they are not running, they are not getting called. But if you see that which are things getting called, see the system one. Look at this GoToMeeting I'm running right now, they're using the CPU and RAM also, so somewhere close to, I think 1.5 GB or something like that. No, it's K, right? So something like that, yeah. 150 MB. See here, in front of you only, the data. It's easy to show in Windows, but you can top command, you can use the Linux, you can see that. So PID, how do we get a CPU and RAM? That's the question. So CPU and plus RAM, from where we get it? So there's one component in every operating system, and we call it a C groups. Okay, I will request you all to do offline studies about the C groups also. Now this user, okay, user's permission, how do you get it? users permission. How do you get it? So there's one component in kernel, and that's called capabilities. Okay. So this is a component which you require. By the way, this all component, user, PID, network, and namespace comes from where? There's one component called namespaces. And then you create a user, you create PID, you create a network, you create ment from there. So these are the components you require to run any applications. I must show you a little bit of visualizations also. So you will have a little bit, memory of these discussions. Okay. So Docker namespace, go to images, open up any images, and look at this here. It's a little faster rather than opening the slides. Look at this. Linux kernel has a C groups. For what? I said for RAM and CPU allocation to the PID. Namespace, this is the namespace we call it. These are the libraries. So this namespace, one namespace create a user, PID, one network, one mint. So these are the namespace. What we have? Capability, here you see. So what they do? They assign this particular user with certain permissions of the system. So all this component is required by in kernel, so applications can run flawlessly. Are you comfortable now?
Yeah.
Hello?
Yeah.
Okay, now let's create one table. Okay, that is a very important table. And this table I'm going to patent it, by the way. Okay, just kidding. Okay, so now need for app. What is the need for one app? I'm telling you. One user you need, one PID, one network, one MNT. Okay, MNT means file system. I'll discuss in a little bit detail in some time. But can and allowed. First, I'll put it allowed actually. Allowed and can. Okay. Now this table you need to understand more or less. Okay. And if you don't hear me very carefully, you will forget this scenario. Okay. So if you get a doubt, please feel free to ask any questions, and you can interrupt me anytime. Okay. So here, allowed means what? I will ask you in simple way. How many users can be created in an operating system? Tell me. How many users you can create in one operating system?
Unlimited.
Unlimited. Yes. Tell me, this is the PID, one PID you need it. Look at this here. So you have a visualization in your mind. See, one PID for one applications, always unique PID. You see that it's coming automatically. If you close the application, it will get disappear again. Next one keep coming in a sequence, keep adding 1+ or something like that, and it will keep coming. So how many PID is allowed in this whole machines? So here n number of. Okay, but here when I say one PID is needed, so this PID is coming from the one thing we call it a PMap. What is a PMap then? So I mean process tree. So what is the process tree? So I will just put it up in this way. See here, this is your 0, which is the mother of everything. You know, everything has come up from nothing. Everything in this from nothing. So here, if you look at this table also, this whole PID structure, if you see, I'm clicking on and going to up, see here 0. Everything has come from the 0. And then here 1 has come. This is your basically running operating system. After that, let's say few extra processes, and then maybe this you logged in. Then after that, someone else logged in. I'm just giving you visualization. Now this user has run one application called Apache. This user has run some application called what is it? Tomcat. See that. So this is a PID 1, 2, 3, 4, 5. But this whole thing we call it P tree, process tree. Will you remember that?
Yeah.
Okay, so here you see how many P tree you have? Only one. Okay, so now how many PID tree Means how many, can you see the PID duplicate ID? No. So how many PID tree you are allowed in the operating system? One PID tree. Okay. How many network you have in one operating system? I'll put it in this way. Let's say you get one IP address. Can you run Apache, two Apache on 80 port? Can you run two Apache on 80 port? No, simple. No. So that means how many network you got it allowed by operating system? One. How many mount you have it? Mount means what? Mount means root file system. Root file system, boot file system, user file system. Now I have to discuss this one, so you'll understand that. What is a mount, by the way? So file system means collections of files and directories for some purpose. Some purpose. Any, the purpose can be anything. So here in every system, you have a boot file system. Please remember, this is a very important concept. And then we have a root file system. And then we have a user file system. And then you have what? App file system. Now, what is a boot file system? Boot file system means it's in kernel. The machine which is booting, the files which is helping you to boot, that's the boot file system. What is the root file system? I think I have shown you in the one session also in Linux. This is the quickest way to show you. Have you seen this kind of file system anywhere? Tell me. See here, there's a root file system. Every Linux and Windows also. In my computer, if you go, you see C drive, program files, Windows, and stuff like that, don't you? Yes. All of you are understanding?
Yeah.
So this is the root file system. What you can see, kernel, this file system you cannot see, but root file system you can see every day. You have to work on it. User file system, simply I'll just go minimize this. This is a user file system. This is a Rajesh Kumar file system in Windows. Anything which is belong to the user space, that's a user file system. And last one, which is a application file system. Any application installed, like let's say Apache, let's say OPT Apache, is an application file system. So now you understand this file system concept, all of you? Yes. All of you? Okay, so in a simple way, I'm asking how many mounts it's allowed in operating system. In a simple way, I'll ask how many C drive you have seen in one operating system. One. Only one. Only one mount is allowed in operating system. So here, guys, understand that kernel and operating system, there's a different concept. Kernel, there's a two kernel in the whole world. I repeat, there are two kernels in the whole world which I know and I have worked with. There are so many other kernels I'm not talking about. There's a Windows kernel, there's a Linux kernel. Okay, Unix kernel is also there, but I'm not talking about out of context. So Linux kernel, which empower all the variant of Linux, like at Ubuntu, CentOS, Fedora, SUSE, all this Kali, whatever the 40 different version of Linux which you have, it's been operating system is powered by Linux kernel. Windows kernel powering all this Windows 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all this version of Windows. So it's very simple. So this operating system allow only one C drive, only one network, one port to be used, only one PID tree, and one on multiple users. Agree with me? Yes. Yeah.
Yes.
Now the question is, have you ever asked a question? This is a very important session and topic in Docker. Have you asked any time, hey, how many, I'm talking about the kernel, okay? How many users can be created, can by kernel, n number of, which is there. How many PID tree can be created? Here is important, n number. How many network can be created by kernel? N many, n network. And how many mounts? N. Then you will ask, Rajesh, kernel can create an unlimited user, unlimited PID tree, unlimited network, unlimited mount. Mount means here root file system, okay? Mount means, I'll put it up, is equal to root file system. File system. Here I'm talking about. So n number of mount can be created. But why this operating system companies are creating only one, and then n number of users can be created? What is the reason for this? If the kernel has capability to create n number of, means unlimited, all these resources, why they are creating only 111? The answer is hidden in the concept called PC. What does a PC stand for? What does a PC stand for? Anyone?
No idea.
PC. We use every day. Personal computing. So understand that this Windows and Microsoft and Linux has come up with the operating system, which is for the PC, personal computing. PC for human. So Linux says, hey, I'm creating a PC. I'm creating operating system which can be used by human as a PC, personal computing, not for running a data center. See, data center concept has come with the popularity of internet, right? Recently, but the PC concept is there from last 40 years. Think about it. So let me tell you here. If I give you 4 C drive and 4 network and a 4 fit tree, what you will do? Nothing. It'll become a very burden on you. Like you will get confused which C drive I should go, which D drive I should go, which fit process ID I should go. So basically, Windows, for ease of using, they enforces one pit tree only, one network and one MNT by default. Whereas you can create n number of users, where because you can work with your family members, colleagues, teammates, and super user, normal user, all these kind of things. Did you understand now why it's allowed only 111? All of you?
Yes.
Yeah.
Okay. So now the question was, what are the components required to run any app? That's a question. So answer is, we need a hardware, of course. You need a kernel on top of, so operating system, you get a kernel which is nothing but a boot file system. Okay. And then top of that, these are the one user needed, one PID needed, PID tree, one network needed, one mount needed, where allowed in operating system only one, sorry, n and 111, but kernel can create n number of all these resources. Whereas we also discuss about the file system concept. MNT means root file system, but typically in operating system, any operating system, you see the boot plus root plus user and app. All of you are okay so far? All of you?
Yes.
Okay. Now my root question was, what is a container? So I will draw a few pictures and then you decide if you understood the container or not. Okay. So here, guys, this is a hardware and this is a kernel. Okay. Now I must write also. This is a hardware and this is a kernel. I'm creating an image. Okay. Now in this kernel, we decided we have a namespace. These are the 4 namespace. So here I will write it. This is the user namespace. Okay, USR namespace, MNT namespace. These are the namespace. Okay, network namespace and what we said, user namespace. No, user done, right? PID namespace. Okay, so these are the 4 namespace you have in the kernel. Okay, now because of that, you know what? I'll just little bit cut it here. Now, because of this user namespace, because of MNT namespace, please mind it. Here we create one MNT. This is the MNT, one MNT. Okay. Now, then because of network, then we create one network here, the one which you see that. Okay, very simple image. I'm not complicating with the 2 minutes image, one network, you got it. But also you can also create PID tree. So this is the PID tree, one PID tree we discussed already. So far so clear, right? All of you? Any questions?
That's okay.
Okay, wonderful. Now I will just cut a little bit and make it down. So guys, here now think simple, okay? Think simple always. You said, you look at this here, this chart, how many users you are allowed to create? n. So here, 1, I'm creating few users just for the demo. 1 users, 2 users, 3 users. Okay, so this is the user. This is also user. This is also a user. And inside that, understand that the problem starts now. The problem starts now. If you want to run Apache here, and you want to run Apache here, you want to run Apache here. 3 users, 3 Apache. Okay. Now the problem start here. Let me ask you one thing. This Apache runs on which port?
80.
80. And assume this is the PID number 50. And then they're writing a file in, let's say, OPT Apache. I'm just for visualization, I'm writing it. Please understand, OPT Apache. Now, other user, do you think he'll be able to use 80? Other user in the same machine?
No.
No. Why no?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to hundreds of playlists and thousands of videos lifetime access with this membership. Enjoy.